Let's look into the design part. So for that, the data is frequency is considered as 200 Hertz and the phase shift at that frequency, that means the maximum possible phase shift between the output and the input, is taken as 30 degree. So with these two data, let's see how to decide the values of R1, R2 and C. So as we know, alpha is given by 1 minus sin phi m divided by 1 plus sin phi m. You should start your design with this equation. You know phi m is 30 degree. So if you substitute that, alpha becomes 0.33. Remember, always alpha value should be less than 1. That is how you can cross check your answer. And then you need to go for another equation. Omega m is equal to 1 over square root of alpha into tau. But you have only Fm right now, so convert Fm into omega m by multiplying it by 2 pi and then substitute here, and with this value and the knowledge of alpha what you have determined in the previous step, you can find the value of tau, and tau value here it is 1.3790 into 10 power minus 3. Remember, always tau should be in order of millisecond. Don't miss this. Okay, 10 power minus 3. And let's move to the next equation. Tau is R1 into C. Right, you know the value of tau. Assume the value of C as say 1 microfarad, and hence R1 becomes 1379 ohms or 1.379 kilo ohms. Then use the last equation, alpha is equal to R2 by R1 plus R2. You know the value of R1 from the previous step and alpha from the first step, and making use of those two, find the value of R2, which is R1 into alpha by 1 minus alpha, and hence it leads to 688 ohms. So after the design, you should draw your circuit diagram, what is designated as practical circuit diagram, and in this circuit diagram you should mention the values of R1. So R1 is 1.379 kilo ohms, R2 should be considered as 680 ohms, and C is taken as 1 microfarad, and your input is given from a signal generator, as your input is a sine wave with a frequency of 200 Hertz. So sine wave, and you fix your peak to peak value to the 4 volts, right? So when you are going to check your circuit, first you adjust frequency to the 200 Hertz and check whether the phase shift is between the output and the input is 30 degree or not. After that, to obtain your frequency response, as I have mentioned in the methodology, vary the frequency of your input, start from lowest frequency 50 Hertz till say some 5 kilo or 6 kilo Hertz. Vary the frequency and note down what is peak to peak value of your output and what is the phase shift between the this is how it looks if this is your input, and since output leads the input, output comes like this, output comes first and then the input, and you will have to measure this phase shift. In fact, from CRO you can measure delta T directly. Already I have explained how to convert delta T into phi. So you will have to find out two things. One is peak to peak value of your output and phase shift between the output and the input for each and every individual frequency, which is going to fetch you the frequency response. Now let's move to the experimental part. So let's look into the connections now. Initially we have the parallel combination of R1 and C. Here this is your R1 and this is your C. So for parallel combination, red is connected to red and black is connected to black. So these two are in parallel, and this parallel combination should go to the resistor R2. So this is your R2. So from here you can take this connection either from here or here, it goes to R2, right? And another end, obviously the input to this circuit should be from signal generator. So from signal generator, the probe positive point goes to the junction of R1 and C. This is the junction of R1 and C, and the negative should go to the another end of R2. So it is connected to the another end of R2, right? And at the same time the input should be applied to the CRO. So I have connected one more probe to the same point where the input is applied, and it is connected to one channel. So let's see how to adjust the input now. According to the given design, frequency is 200 Hertz, so I have set it to 1.98 into 100, so it is 200 Hertz. If the frequency is 200 Hertz, then its time period is reciprocal of that, it will be 5 milliseconds. And here you can see that from here 1, 2, 3, 4, 5. So it is exactly 5 into the multiplication factor is 1. So it is a sinusoidal waveform of 5 millisecond or having a frequency of 200 Hertz. And for the experimental purpose, the amplitude of the input should be kept constant. Here it is peak to peak amplitude is total 4 volts. So from the reference it is plus 2 and minus 2. So total it is V peak to peak it is 4 volts. In order to observe the output, we need to connect a CRO. So the second channel of CRO, that respective probe, it is connected. It should be connected across R2. So the respective probe, it goes to R2. It is connected between the 2 points of R2. So now let's see how the output comes.